to the Tuesday discussion today with Dr. Leonard Burtscher. My name is Christoph Mauch and I'm the director of the Rachel Carson Center, and together with Dr. Lisa Lüdecke, the director of graduate programs, I'm convening and moderating the Tuesday discussions. We're alternating and it's my turn today, and it's a great pleasure to welcome Dr. Burtscher with us. We met him recently, some students, and I met him recently at the Umweltinstitut where he works here in Munich. And but he's here for a different reason today. Leo, originally Leonard, comes from Bavaria, actually from a village that is quite unknown, but I love it because there's the best blues place in Germany. It's in a mill, totally remote place, one of the darkest places in Germany, and when he grew up there, it was even darker. And I wonder whether he became an astronomer because it was so dark there, because in that place, with no street lighting, you could see the stars more clearly than from anywhere else, probably. And he went to study astronomy, got his PhD in, well, he studied in Scotland, I think, and in various places, but got his PhD at the Max Planck Institute in Heidelberg and the Astronomy Institute in Heidelberg, got a postdoc in Garching in extraterrestrial physics, so he's a physicist, and he was a research professor and a staff member of the famous big observatory in Leiden University, in Leiden, one of the ELTs, the extra large telescopes, ELT, the one called, what is the name?
It's just ELT.
Okay, but it had a name.
It used to be called ELT for European ELT.
Oh yeah.
They renamed it to make possession of the whole acronym.
Oh, okay. But wasn't it the Metis one, the wisdom one?
That's the instrument, yeah, the camera for the ELT.
Yeah. So he knows something about big instruments. He knows something about astronomy, and in contrast to many of the astronomers who love to be in the air, jet setting around the globe because that's their research field. He decided that it's important to think about what's happening on the Earth, not just what's happening out there, and he decided to leave one of the positions where he could have stayed forever in Leiden University or the observatory, and come to Munich and start here basically as an activist in an NGO in the Munich Umweltinstitut. And in contrast to the jet setters, he's somebody who is usually coming or going wherever he goes, not when it rains like this, but on any other day by bicycle. So I'm excited to learn about the initiative that you're one of the starters. There are only 2 people, international coordinators of this global movement, Astronomers for Planet Earth. And we are really lucky to have Leo here because one of the 2, it's in many, many places on Earth. It's a huge network. It only started a few years ago, but it's already a huge network. So please join me in welcoming Dr. Leo Burtscher.
Oh, good afternoon, everyone, and thanks a lot for the nice introduction, Christoph. It's a pleasure to meet you all and to see the Rachel Carson Center here. So indeed, in the next 10 to 15 minutes, I'll try to give an overview of what brought me from astronomy to, so to say, down to Earth again. And I will first give you a little glimpse into astronomy, because that's always fascinating, and then try to take the turn of looking back on Earth, and in the last few slides say a little bit about the organization that I indeed co-founded 3.5 years ago now. So if we are lucky enough to see our Milky Way, which indeed I was as a kid growing up in rural Bavaria, then what you see is plenty of stars. These are all stars and some dust clouds in between. If you're in the southern hemisphere, you can see these neighboring galaxies, the Magellanic Clouds. But even if you look up here, if it's dark enough, you see just a tremendous amount of stars. And by now, the last 20, 30 years or so, astronomers have discovered essentially how stars are formed over time. You might recognize this constellation. This is very well visible still at the moment in the very early hours, usually in winter. It's the Orion constellation. Orion spelled here, and in the center here you can see the Orion Nebula, one of the most famous so-called nebular clusters. And this is one of the places where stars are made. This is how it looks like in big, as observed with the Hubble telescope. And all these wonderful colors and all these shiny stars here, or all these wonderful colors come from young stars emerging and producing lots of UV radiation, ultraviolet radiation, and therefore exciting the gas that is around, and then putting it into all these fancy colors. And after learning how stars formed, we also learned how planets form. And this is something that is relatively recent. This image here was taken about 10 years ago or so with one of the largest sub-millimeter radio telescopes on the Earth called ALMA in Chile. And what you can see here is essentially the glow of dust around a very young star that is just a few million years old. It's young for stars, get billions of years old. And you can see a disk that is, if you saw it from the side, it would be relatively thin. And you see a disk of dust with some gaps in between. And these gaps are not just places where there isn't any dust. I mean, yes, there isn't any dust, but the reason for that is that there is something bigger that has removed the dust. And these bigger things are planets. And we understand these days that these are the places where planets grow. So we understand how many stars we have, we understand how stars form, we understand how planets form, we understand these days that there is everywhere planets. Everywhere we look at every young star form, at every young system of stars, we essentially see evidence of planets forming. And we believe now that planets are kind of a byproduct of star formation, because in order for a star to form from a big cloud of molecular gas, it needs to collapse and get rid of its angular momentum, Drehimpuls in German. And to do that, it has to either blow apart or produce some tiny particles that take away that angular momentum, so that they keep all that fast rotation. And this is planets. So planets are a byproduct of star formation. We understand this these days. And we understand that there's billions of stars, literally billions of stars in our Milky Way alone, our own galaxy. And we know, of course, as well that there is neighboring galaxies. If you're again lucky enough to be in a very dark place, you may be able, and if you have good eyes, to see this galaxy, the Andromeda galaxy, the nearest galaxy, proper galaxy, not like the Magellanic Clouds, which are just satellites of our galaxy. This is the nearest galaxy, really real galaxy. You might be able to see it with your bare eyes. And this is a galaxy very similar to the Milky Way in size, and it again has billions of stars. And then if you look deeper into the universe, we see that there is billions of galaxies, literally, again, billions of galaxies, each of them containing billions of stars. And each of these stars might contain a couple of planets, perhaps 1, perhaps 5, perhaps 10. We don't know yet. But what does this all tell us? I mean, this is super amazing, and I'm still fascinated just by talking about it, I have to say. But what does this all tell us? And does it tell us anything about this question that is really in the center of so many discussions that we have on Earth at the moment? Is there a planet B? Do we have a second planet that is just like the Earth? Well, some people dream of colonizing Mars. Fascinating idea, again, if you can read, if you know the book The Martian, or the more sciencey book, the Mars trilogy, Red Mars, Green Mars, Blue Mars. This is really fascinating to read. And I believe it might be possible at some day to colonize Mars. But perhaps in, 100 years or so, perhaps 5 people will live there, perhaps 50 people, I don't know. But it's not a solution, obviously, for the problems we have on this planet now. Also, can we travel to other planets? Well, we know 5,000, for sure, have seen, so to say, 5,000 other planets so far. And indeed, the instrument on which I worked until a year ago, its main aim is to take a picture of the first picture of an Earth-like planet. We know that these planets exist, not necessarily an Earth-like planet, we haven't found that one yet, but we couldn't travel there. The universe is just too big. It's just way, way, way too big. If we wanted to travel even to the nearest star, which is about 3 light years away, with current technology, it would take us ages. It would take us tens of thousands of years to just get there, and then we still would have to brake, which would be very difficult too. So it's just impossible, at least in the near future, before we invent warp drive, to get to any of the nearby planets. And as someone said, if these nearby planets are so nice that we can live there, perhaps someone else is there already, and perhaps they don't like us. There's all these problems, so we should really make better use of our own planet, obviously. And just to show how empty the universe is, I brought this picture, which in my view is one of the most amazing pictures that everyone in the Rachel Carson Center should definitely know of. The picture is called the pale blue dot, and the idea came from the American astronomer Carl Sagan, who was one of the scientists on the Voyager 1 space mission to the outer solar system. And he asked to take a picture of the solar system after the space probe has essentially observed what it had to observe, the outer planets. And so the space probe turned around, which was very risky because the antenna with which it communicated to the ground station on Earth was on the other side. And so if had the program to turn it around again after that initial turn not worked, we would never have received that image. So a very risky maneuver, but nevertheless they did it, and they took a picture back from behind Neptune essentially of the inner solar system, and they found this, an empty piece of black essentially, right? But if you look very closely, you can see that this is us. This tiny, tiny spot that's a quarter of a pixel on this image is just so amazing because this is really all we know. And Carl Sagan wrote a book about this, The Pale Blue Dot, a very interesting read. And one of the core messages I'd just like to read to you is this. To me, he said, this image underscores our responsibility to deal more kindly and compassionately with one another and to preserve and cherish that pale blue dot, the only home we've ever known. And I think that's really, this is one of these moments that to me still gives goosebumps if I just see this huge vastness of nothingness, knowing all these fascinating images and everything that's out there, but then looking back and seeing this is really all we have. And this effect is actually well known, especially among astronauts, so people who actually go to space, not just talk about it. And that's called the overview effect. It's well known among astronauts who first go into Earth orbit, or even more, who actually leave Earth orbit to go, for example, to the moon. Well, not for example, it's the only other place we've been. And when they look back to Earth, what they see is Earth as a planet, as a whole. And it's called the overview effect. And it leads, people say, to strong psychological changes in the behavior, to an understanding of this is really all we have, and we really need to be more kind to one another. If you're more of the sciencey kind, this is one of the images that I think shows very, very well what the problem is. This is a view from the International Space Station, just about 90 kilometers above ground, and this shows you how thin our atmosphere is. This is really, 10 kilometers is the scale height of the atmosphere. That's really all we have, and we're adding and adding and adding carbon dioxide and methane and other stuff to it all the time, since decades. No wonder that things are changing. And things are changing very, very quickly. Right? We know these days from so many different indicators. It's not just the global warming that is observed, that of course is a big problem, but there's, in recent days, there was a lot of press coverage about the ocean warming. The oceans have actually covered and absorbed much more of the extra heat, the excess heat than our atmosphere. And that is highly troubling because water has a very high momentum, so to say, to temperature change. And if the water is getting warmer, that means a really large amount of energy is stored there. And we need to get rid of it again at some point if we want to go back to the initial level. You see sea level rising, of course the atmosphere is warming, the sea ice is melting. Lots and lots of indicators show us that really something is happening to the atmosphere. We don't fully understand yet what that means, which to me is not a good sign, but it actually means it's a warning sign in addition, because we don't really know what this means. Now, when we made this connection as astronomers about 3.5 years ago at a conference in southern France where it was extremely hot and we realized these heat waves are going to come even more frequently in the coming years, we asked ourselves, okay, what can we do as astronomers? And we identified essentially 3 points that we thought are tackle points that we can work on immediately. One is we can and we should reduce our own emissions. And astronomy is a very carbon-intensive business. We use a lot of energy. These wonderful, fascinating observatories in the middle of nowhere are all, of course, driven by energy, and up to now, most of them still by fossil fuels. So that needs to change, and it needs to change quickly. We're flying around a lot, and that is one of the most detrimental impacts you can have as a single human being to our atmosphere, taking a long-distance flight. But also, and I deliberately put this as number 2, because I think we first need to lead by example and show that we take this seriously, despite all the importance and all the fascinating, amazing things that we discover in astronomy. We need to reduce and change the way that we're doing things, just to show by action that we're actually serious about this. And once we've done that, we can talk about this. And we can talk about the astronomical perspective, the pale blue dot, and how amazing our Earth actually is, and how much we have to preserve it. And point number 3 is we can lend our voice to the public debate. People love to listen to scientists, as I'm sure you've all discovered yourselves, and especially to scientists who have something nice to show. And you can use that, not abuse, but really use that and show what the other sides of this are. When people see pictures of black holes, of course that's amazing. 1 billion people have seen the first radio image of a black hole 3 years ago of M87. But this is the same science and technology that shows us that the Earth is in a climate crisis. So we founded an organization called Astronomers for Planet Earth. It was founded in 2 places at the same time, essentially, and I mean, we're kind of you, Christoph, to say that yes, I'm one of the 2 international coordinators, but we're really a large team of this. We're nearly 2,000 members by now, and we're approximately 50 or so people who are very active and all at the same level. We're a grassroots organization with no hierarchy, and we have everyone here from famous exoplanet researchers to outreach professionals, to planetarium presenters, to space science experts, to all sorts of people. And they all join us in this mission with essentially 2 goals. One goal is really to provide the public with information, to bring the astronomical voice to the climate movement, and the other one to be the climate movement within astronomy. And we see this as 2 parts that have to go together. And just as a last point, our mission, therefore, as we phrased it very recently, is to mobilize and empower the global astronomical community to take action on the climate crisis. This is really what we want to do. And to that purpose, we're about to found a charity, eingetragener Verein in German, in the next month, actually. We will be then a legal entity, and we will try to acquire funding to do more of what we love to do, to give talks, to give presentations, change or add planetarium presentations that have that component of looking back on Earth and reflecting what all these wonderful astronomical discoveries mean for our everyday life. I was asked to be not much over 10 minutes. This is 13 minutes, and therefore I'm done. And if you take just one message away from this, I would like you to keep the message: there really is no planet B. Thank you very much.